we have continued that work under the umbrella of pre-market testing, filling those data gaps, trying to identify mechanisms of harm, and also trying to prescribe, based on understanding those mechanisms, primary, secondary, and tertiary interventions that would be appropriate for people who have been harmed by the radiation. So we have moved forward addressing this problem as a public health and safety problem with science aimed at identifying interventions. We do not look at this as a public relations problem. We do not look at this as a scientific debate problem. As others around the world may be doing research intended to cross the T's and dot the I's and in effect count bodies, we are working on saving lives. So that is the context within which my remarks are made to you today. Now, what we understand now, today, from our work over the past 4 or 5 years is the following. Within the electromagnetic spectrum, we now know that there are 3 very distinct effect windows. And in those 3 distinct effect windows, there are 3 distinct mechanisms of harm that operate to cause ill effects in some people. Within the ELF window, the extremely low frequency window, where the magnetic part of the electromagnetic field is dominant, the mechanism of harm is direct magnetic effect. There is a threshold within that window, meaning that there is a level below which there are no adverse effects. The threshold is breached when a large amount of power is used to push the ELF wave. At the high end of the electromagnetic spectrum, we have ionizing radiation. That's a different effect window. The mechanism of harm in the ionizing radiation effect window is high energy breakage of chemical bonds. That is a direct effect, and in terms of clinical response, we have a threshold. The effect window in between is the radio frequency radiation effect window. And what we have now found is that the raw radio frequency wave, 1900 megahertz, oscillating at 1900 million cycles per second. To be put in context, your heart beats at 2 hertz, 2 cycles per second. Radio signal beats at 1900 million cycles per second. Those high oscillations are not recognized by biological tissue. It is only because information has to be carried on those waves that data packets have got to be put on top of those waves in the form of modulations. That is why on either end of a phone call, you can hear voice, receive data, instead of simply hearing nothing. Those modulations form a secondary wave. We call that the information-carrying radio wave, that secondary wave. And that information-carrying radio wave oscillates in the radio frequency, depending on where you are, from low hertz to low kilohertz. That information-carrying radio wave is recognizable by biological tissue. The mechanism of recognition is protein vibrational receptors on the cell membrane. Now, when a protein vibrational receptor recognizes an information-carrying radio wave, it interprets that information-carrying radio wave as a foreign invader to that cell. The reason is because in nature, information-carrying radio waves do not exist. That we have not developed a compensatory system over evolution, the way we have for magnetic fields and also for ionizing radiation. When recognition occurs, which happens within milliseconds, within 3 to 5 seconds, the cell membrane interprets this information-carrying radio wave as a foreign invader, and within 30 seconds, a series of biochemical reactions ensue which are intended to help the cell protect itself. Among the first of those biochemical reactions is a sliding of the protein and lipid layers on the cell membrane, which closes down the active transport channels. So the cell membrane becomes less permeable, and nutrients are now able to get into the cell. When nutrients cannot get into the cell becomes energy deficient. And we have now seen that when a cell becomes energy efficient, the first thing that is compromised is microtubule-based intercellular communication, photon communication between cells. The cells cease to be able to talk to each other. This is very important because on a cellular molecular basis, when cells are able to talk to each other and do work together, they form tissue. And when tissues are able to talk to each other and do work together, they form organs. And when organs are able to talk to each other and do work together, they form organisms. And when you disrupt that process of intercellular communication, you cause symptoms instantaneously. So the disruption of microtubule-based intercellular communication is the first thing that happens when the protective responses at the cell membrane level ensue. While nutrients cannot get into the cell, waste product cannot get out of the cell. And as waste product builds up inside the cell, you have increase in concentration of free radicals. Those free radicals are highly reactive. And like the free radicals in the 60s, they love a party, and the party in the cell is going on at the mitochondria. So the first place those free radicals go are to the mitochondria, which is the respiratory center of the cell. Buildup of free radicals disrupts mitochondrial function. And when the cell cannot function properly, it can't do its job. And when the cell can't do its job, it's a dysfunctional cell. So one pathway of the mechanism of the buildup of free radicals is cellular dysfunction. This is consistent with what we found, for example, in leakage of the blood-brain barrier. The other thing that happens is that you have high concentrations of free radicals floating around in the cytoplasm, the inside the cell. And on the endomembrane, the protein inside the cell, you have messenger RNA. And when the cell is chronically under this state of stress, where the active transport channels are shut down, it changes the way messenger RNA folds. The messenger RNA takes that information that the cell is under siege and converts it to the DNA in the mitochondria and the DNA in the nucleus. You have an environmentally induced genetic change. And when that cell goes through mitosis, the daughter cells carry the new genetic information. As that process continues, and over several cell cycles, you have daughter cells with information indicating that they are under siege when they maybe not. You have a clinical syndrome called electrohypersensitivity. That is the mechanism for electrohypersensitivity. When the free radicals interfere with DNA repair in the cytoplasm, you have fragments of DNA that are not able to recombine properly. We have found, and others have found, that those fragments of DNA that can function well enough to form a membrane around themselves form what we call micronuclei. Micronuclei are pieces of DNA in the cytoplasm of the cell. They have membranes around themselves, but they have no constructive purpose. They have no constructive function. When the cell goes through a process called apoptosis, apoptosis is programmed cell death. When a cell knows it can no longer do its job, it commits suicide to make room for a new cell to come in and start up the work. When that happens, the cell membrane disintegrates, and micronuclei that are inside the cell are now released into the interstitial fluid between cells. Under normal circumstances, micronuclei would be recognized as a foreign substance, and a message would be sent to the immune system to recruit macrophages and T cells to come and take the micronucleus away. But this is not a normal circumstance because the cell is energy deficient. Intercellular communication is compromised, so the message doesn't get to the immune system. So now you have a micronucleus sitting in the interstitial fluid that is nutrient rich because nutrients could not get inside the cell. And now that micronucleus is free to clone and to proliferate. And that is consistent with the mechanism we have for the development of tumors. Where you have a biological mechanism like this that is triggered by recognition at the cell membrane level, you have no threshold. Meaning, there is no level below which this mechanism is not triggered. What we have done in the Safe Wireless Initiative is to use this information to identify ways that we can intervene so that people do not have to suffer from the effects of information-carrying radio waves. Our paradigm for intervention is the public health paradigm. And that includes primary, secondary, and tertiary intervention. Primary intervention has to do with eliminating the exposure. Secondary intervention has to do with minimizing the effects or eliminating the symptoms. And tertiary intervention has to do with repairing the damage. There are now technologies available that offer primary, secondary, and tertiary interventions. Because those types of interventions are available, and because most of our work in the Safe Wireless Initiative is derivative of our registry, we have tens of thousands of reports now in our registry from people who believe that they have been harmed by electromagnetic radiation in all the different windows. And because our focus is on clinical information so that we can help patients,